There we go. Okay, so yes, good afternoon, everyone, and welcome. So wonderful to see many of you here. Oops, the slide disappeared. Many of you here, and of course, I know others couldn't be here as well. It's fantastic. We're recording this just FYI so that we can post it later. Dr. Kremen was generous enough to allow us to record it, so we appreciate that. And of course, we'll get to the keynote in a moment here to give you a sense of what we're going to do this afternoon. I'm just going to give a very brief overview of the STEP program. This is, as the last slide indicated, our keynote seminar for the year. So we want to take the opportunity to give a little bit of an introduction to the STEP program itself. Dean Amy Suplanant, I mean to say, of the graduate school here at Virginia Tech is then going to, has kindly agreed to give some introductory remarks. We'll have the keynote talk, of course, with Claire Kremen. Jeff Walters, biology, Harold Bailey professor in biological sciences here, has kindly agreed to kick us off with a bit of a response after the keynote, and then we'll open it up to Q&A. What I did want to flag at this point, we were just discussing a moment ago to make sure we're on the same page. What we're going to do in terms of Q&A is please use the Q&A function at the bottom of your screen in Zoom. And so you'll see a Q&A button down there. And what's nice about that is you can put your questions in. If you want to upvote people's questions, you can do that. It just provides a nice vehicle for the collection of questions. And we'll try to get, of course, to as many questions as we can during that time. So as I said, we'll spend just a moment here giving a brief introduction to the STEP program, since this is the STEP seminar. And so the STEP program is a relatively new initiative here at Virginia Tech. I think we officially got our governance approval just over a year ago, February of last year. And it's an initiative of the policy destination area here at Virginia Tech. And to that end, I certainly would like to thank the stakeholder group. And in particular, I'd like to thank for today, Isabel Bradburn, the program director, for in particular, the whole group, but particularly Isabel's support with this, in particular with this event, pulling it together. And so the policy destination area initiated the STEP program as a way to focus on the intersection of public policy and the STEM-H fields broadly understood, and how we can be more effective actors at that science policy interface, introducing STEP participants to the implications of the science and technology that we generate and use, to the ways in which policy is constructed, the policy process, if you will, and to the ways in which those intersect. That is to say that science, technology, and so on intersect with policymaking processes. And so our aim with the program is to enhance the capacities of those STEM-H students, practitioners, and scholars to be effective participants and collaborators in policy processes. The program aims to develop participants' abilities to engage with complex public problems, recognizing that they are social and technical in nature. And our ultimate goal, which I think is reflected in that first statement, is to develop and enhance participants' understanding of policy processes and capacity to engage scientific and engineering knowledge with public policy reasoning. At this point, certainly we are primarily targeted, and I'll come back to this in a moment, primarily targeted at graduate students within our community, within the Virginia Tech community, but we certainly also have avenues for engagement with other stakeholders, faculty, staff, undergraduate students, and external partners, and we certainly look to enhance or increase those over time. So I'm going to go through a couple of slides here. We're obviously not going to read all the text on them, just to give you a sense of some of the different dimensions of how we examine that science policy interface. And if you'd like to see more of this, if you'd like to read the fine print, if you will, of course, this is all on our website. So you can visit www.step.vt.edu to learn more. So as I said, we focus on how policy is made, introducing that process. We certainly focus on the intersections of values, ethics, and interests in that policy making. We focus on ways in which we can engage various stakeholders in collaborative processes more effectively, recognizing that policy at its best is a multi-stakeholder process. We examine how and we help participants become better communicators, so how they can engage with stakeholders, recognizing communication as a two-way street. We focus on, in particular, in that communicative process, the ways in which scientific and technical information integrates with policy processes. And we do this, as I said, primarily at this point through a set of courses and a graduate certificate that are aimed at graduate students. And so graduate students across Virginia Tech, and certainly we're open and have attracted a wide variety of students from a wide variety of different disciplines, are open to take these courses a la carte. So any of these courses are open, or to take them all on their way to completing our graduate certificate, which involves these 4 courses or requires these 4 courses, plus a minimum 2 credit, a related course in their field, and or a great highly recommended course here at Virginia Tech, the Communicating Science course, which also provides those 2 credits. So that's our graduate certificate, which we think is a nice option for students here to consider. Last but not least, I would just say that certainly we are always open to, and this is a shameless plug, I suppose, to various faculty, staff, and so on out there that are looking for ways to think about this way in which you might integrate this with what you do, is we're always looking for partnerships, and certainly one we're extremely proud of and grateful for. Kind of our biggest partnership so far is with this new NRT program. We have National Science Foundation Research Traineeship program on the convergence at the interfaces of policy, data science, environmental science, and engineering for combating antimicrobial resistance. And so this is a great program, obviously on the topic of antimicrobial resistance, but a great opportunity for participants, students, trainees that are a part of this program to receive the STEP certificate as a part of their core training, while also, of course, engaging in the substance of thinking about those intersections around this really important topic. So with that, I will hand it over, here we go, to Dean Amy Supranong to provide some introductory remarks. I'll stop my share.
Thank you so much, Todd. A few weeks ago, I was introduced to the Science, Technology, and Engineering and Policy program and its graduate certificate. And I was immediately excited about the opportunities and experiences that it affords our students. As scientists and scholars at a land-grant university, it's our obligation to contribute to the Commonwealth by sharing the fruits of our labor. So we have to help those in position to make big decisions about social and economic development and prosperity using evidence-based, data-driven information. But if we can't effectively communicate the importance of our work, and on the other hand, if we don't understand how policy and decisions are made at those levels, we can't have an impact. And very few scientists and scholars are trained in both the intricacy of their field, but then also how to make real change in policy at any level. So this program and its certificate is quite innovative in this space, including helping scientists engage with policymakers using their technical knowledge to tackle complex problems. So I'm so pleased to support this program from the graduate school, and am very eager to see what they do next and to help with whatever their goals are. So now it's my very great pleasure to introduce today's Step 22 keynote speaker, Dr. Claire Kremen. Dr. Kremen is Professor and President's Excellence Chair in Biodiversity at the University of British Columbia, where she leads the Interdisciplinary Biodiversity Solutions Cluster. Her current research focuses on how to improve the connectivity and sustainability of farming landscapes through agricultural diversification. Before coming to UBC, she held faculty appointments first at Princeton University, then at the University of California, Berkeley, where she was also founding faculty director for the Center for Diversified Farming Systems and the Berkeley Food Institute. Prior to those appointments, she worked for over a decade for the Wildlife Conservation Society and the Xerces Society, designed protected area networks, and conducted biodiversity research in Madagascar, a biodiversity hotspot. Her work both then and now strives to develop practical conservation and sustainable land management solutions while adding fundamentally to biodiversity science. For this work, she was named a MacArthur Fellow in 2007 and a Volvo Environment Prize laureate, I'm losing my ears, in 2020, along with other honors, and is a highly cited researcher. And since 2014, she's had over 150 publications. She's also chief editor of Frontiers in Sustainable Food Systems. The title of our presentation today is Managing Landscapes to Reduce the Triple Anthropocene Threat. So please join me in welcoming Dr. Kremen. Dr. Kremen?
Hello, everyone, and thank you so much for having me to this series. And it was wonderful to learn about the interesting STEP program that you're just embarking on. I especially want to thank Isabel Bradburn for inviting me. She's a long-term friend and family friend. So it's a great pleasure to be here. And I'm hoping that you are seeing the full slide and not the presenter view. Is that, can you give me a thumbs up on that?
Yes.
Yeah, okay, great. So as I'm sure you're very, very aware, the news out there hasn't been particularly good news on the environment. In 2019, the Intergovernmental Panel on Biodiversity and Ecosystem Services, a global assembly that essentially assesses biodiversity and ecosystem services in different regions of the world and around the world, came up with a statement that 25% of each species group is threatened with extinction, about 1 million species, in other words. And this brings with it that ecosystem services are also at risk, of course, with huge impacts on humanity because we rely on these ecosystem services and the fundamental biodiversity that supports them. And then more recently, just very recently, the IPCC 6th Global Assessment is saying that climate change is now a major cause of species and ecosystem endangerment. It certainly has very obvious current impacts on society that we're all very aware of. And the projections in this last report are really dire for anything greater than a 1.5 degrees centigrade increase. These aspects are very interrelated. The climate change and biodiversity loss are really are inextricably linked. They affect one another, and they are driven by the same root cause, which is the unsustainable extraction and consumption of resources. But just as these two issues affect and exacerbate one another, we can also find solutions that work in favor of both. And this was actually recognized in this last IPCC report, where the human action of conservation and restoration using ecosystem-based approaches or nature-based solutions can lead to these biodiversity-driven adaptation and mitigation, which are the green arrows here, as well as the provision of ecosystem services that promote human livelihoods. So I'm going to focus on agriculture. It's a leading contributor to both biodiversity loss and greenhouse gas emissions. Of course, through tropical deforestation and then generally through the expansion of agriculture, it leads to great habitat loss. And because agriculture is such a dominant land use, about 40% of terrestrial land use is agricultural. This is a huge factor on biodiversity conservation. And it also is a huge factor for greenhouse gas emissions, about 30 to 35% of which are due to agriculture. In addition to the habitat loss and fragmentation from agriculture, there are many other impacts of agriculture on habitats, such as through nutrient and sediment pollution of both freshwater and marine aquatic habitats. Also the use of agricultural toxins, both in the crops and the effects of those ramifying through field chains, through food chains and into adjacent landscapes. And then on the greenhouse gas emissions side, again, not only due to deforestation, but livestock production is a great source of greenhouse gas emissions, as is irrigated rice and both the production and use of synthetic nitrogen fertilizers. So changing agriculture with nature-based solutions needs to be a major focus if we want to tackle the issues of both biodiversity loss and climate change. And this is where the working lands conservation concept comes in. This is a concept of protecting biodiversity in spaces shared by people and nature, and focusing on our working lands where we grow food, fiber, fuel and energy, forage, and forest products. In other words, our farmlands, our forests, and our rangelands that are managed for this production. So the working lands conservation concept is the idea of managing these lands sustainably and using this concept of nature-based solutions to produce a basket of goods and services for humanity that includes not only the production piece, the forest products, the livestock, and the crops, but also the production and sustenance, maintenance of ecosystem services that we need to continue the production of these other goods. So healthy soils, fresh water, carbon sequestration, pest control, and pollination services. And these ecosystem services are essential to maintain human well-being and its adaptive capacity and resilience in the face of global changes. And the last component is the biodiversity piece. This biodiversity can be promoted through within our working lands that we manage for these other goods and services if we provide habitat for biodiversity, but it can also influence biodiversity in a positive manner by maintaining the connectivity of our landscapes and making them more permeable to animal movements such that we can enhance the persistence of populations over time. And lastly, this biodiversity, of course, is fundamental for sustaining ecosystem services. So some examples of working lands conservation are land management techniques that date back millennia. For example, the Dehesa forests of Spain, which occupy about 8,000 square kilometers in that country. This is a type of oak forest that has been managed for centuries through both clearing the understory, spacing out the trees, and also some burning practices. And it produces a number of different products like the black Iberian pig, as well as non-timber forest products like mushrooms, honey, cork, and aromatic wood. And at the same time, it supports some threatened charismatic species like the Iberian lynx and the Spanish imperial eagle. But others of these working lands practices and nature-based solutions are very new and in fact constructed scientifically, such as this push-pull system that was invented in Kenya by a number of different organizations, ICIPI, the Kenya Agricultural Research Service, and Rothamsted Research in the United Kingdom. And this is a system of integrating with the maize production to other species into the field. So we have the Desmodium planted, which fixes nitrogen and helps to control a striga weed, which is one of the main pest issues. And then the Napier grass is planted along the outsides of the field, and it's important for helping to control the corn borer, which is the other major pest issue. And there's a complex chemical ecology that has been worked out of push and pull factors here that help to control these two problem pest issues. And at the same time, because they also fix nitrogen and produce these forage grasses, it actually helps to produce a lot of other goods and services and helps to empower women through forage production that helps to create better livestock and milk production. So more generally, there are many well-known practices in agriculture that are multifunctional and that fit with this notion of working lands conservation. And here I've arrayed them from a very small scale, from subfield up to the whole field level to the landscape scale. And I want to illustrate three different principles of these kinds of methodologies. The first is diversification over space and time. So we can go from the left side of the graph in red. We can have much more diverse arrangements of crops on the field at one time. We can also integrate animals into the fields and use compost to essentially provide both nutrients and also more resources and habitat for the whole subsoil food chain. And then moving up in scale, we can have crop rotations and cover crops and a system of fallowing that changes over time and again diversifies at the whole field scale what is growing in the crop and in adjacent crops. And then around the field, we can have hedgerows and buffer strips that provide different types of vegetation. And then moving up to the landscape scale, we have riparian corridors, woodlots and meadows, and much more landscape level heterogeneity by also including natural habitat patches. So you can see that we can have diversification at all of these different scales from the subfield up to the landscape, and create a lot of heterogeneity. And this is important because it ends up providing a lot of important synergies that help to promote the kinds of aspects that the farmer actually needs, the nutrient cycling, water management, soil fertility, pest control, and pollination. So I'm just going to kind of thumb through these. There's lots of literature supporting all of these positive linkages, and this is the synergistic aspect that I'm referring to. And then finally, the third principle is the regenerative nature of using these diversification practices. By these practices themselves diversify, but also support multiple other organisms in the environment that actually provide the ecosystem services that are needed. And that's the regenerative nature that I'm referring to. So in this talk, I'll ask the question, can working lands conservation simultaneously enhance biodiversity and ecosystem services while maintaining production and promoting resilience, including climate adaptation? And I'll illustrate this with two examples, a South American silvopasture example, and then a couple of examples from North American Midwest farming systems. And then finally, pull it together with several different review syntheses. And then I want to turn to what the barriers are to adoption of these methods, and discuss a promising avenue to scale up adoption of working lands conservation. And then I'll end with speaking about what working lands conservation could look like from landscape to global scales. And I want to emphasize that I'll be drawing on work from many sources. Some of it is mine, but much is also from colleagues. So starting with this first question of, can working lands conservation simultaneously enhance biodiversity and ecosystem services while maintaining production and promoting resilience, including climate adaptation? So I'll start with the intensive silvopastoral system. This is a system that uses diverse forages. So instead of a grass monoculture, it's got many different kinds of plants. You see here both grasses, shrubs, and trees. And these are all edible, so that the cattle can eat all of them, and this actually improves their nutrition and health and leads to higher meat and milk production. In addition, the shading enhances animal welfare, especially during hot periods, and it stores carbon. The trees store carbon. The multiple strata provide habitat for multiple elements of biodiversity. And then finally, it's a regenerative system. The manure from the cattle is going back into the system. Some of the shrubs are nitrogen fixing legumes. And then the deep roots of the trees can actually bring both water deeply into the soils, as well as through root exudates, they can help to generate carbon into the soil. So we have fertile and drought resilient soils. So I'll be showing you several graphics that look like this, these spider diagrams. And in this case, we're comparing in the green this intensive silvopastoral system with these multiple different elements, different kinds of vegetation being used against a grass monoculture. And this is simply a comparative diagram. So in terms of the ecosystem services for farmers, there's a lot of nitrogen fixation going on in the system. And for that reason, they don't actually have to use any nitrogen fertilizer. So that's a big win in terms of their bottom line. They also don't need to use any pesticides to control ticks on their cattle, because there's natural tick control in the system. And other ecosystem services include the carbon that's sequestered by adding trees to this mixture. In terms of production and profit, these silvopastoral systems are much more profitable than the grass monoculture due to enhanced daily weight gain and also enhanced daily milk production in the silvopastoral system compared to the grass monoculture. And then as far as climate mitigation, they also are important because, as I mentioned before, livestock is a big source of methane emissions, but here methane emissions per ton of meat produced are actually reduced. There's also an important aspect that there's actually a reduced land area needed per ton of meat produced. And that's important not only for climate mitigation, but also for biodiversity conservation, as I'll discuss a little bit later. And then finally, on the biodiversity side, although not all of the species found in adjacent tropical forests would be found in such systems, they definitely have much more species richness, looking at birds, than would grass monoculture systems. So here's what some of these silvopastoral systems look like. There's a planted silvopasture that's outlined in the dashed blue. There's also, in this particular figure, there's silvopasture also happening in the native forest on the left-hand side of the image. And then in the front are recently seeded grasses. It's the beginning of setting up a silvopasture on these compacted soils. So it's being used actually also as a way of restoring actually degraded degraded agricultural soils from continued use of grass monocultures. And this is the same image, but somewhat later in time. And as I mentioned, the biodiversity benefits are actually multiple here. So it's providing the intensive silvopastures that you see outlined in the blue are providing some habitat, but they're also helping to restore connectivity in the landscape. And then one of the most important features is that by promoting livelihoods through this highly profitable enterprise, and by restoring these degraded soils, they're actually preventing the expansion into more pristine or undisturbed forests, because instead of simply abandoning these fields that have become degraded, they're actually restoring their productivity. So that's preventing habitat loss that would otherwise happen. And these systems are actually remarkably resilient to drought and heat stress. I have a contact in Colombia where these systems are being implemented and expanded. Zoraida Kale, she sent me this information about a drought that was happening a few years ago. She wrote, "Right now, the Cesar River Valley is enduring a terrible drought, and the only cattle systems that have more than enough fodder for the animals are the intensive silvopastures. Conventional treeless pastures will not survive climate change in the dry Caribbean region." And I thought that was a very compelling statement. So moving on to another example, a very different one. The US Corn Belt is one of the most intensively farmed regions in the world, and it's responsible for a large dead zone in the Gulf of Mexico because so many of the agricultural chemicals are running off into the Mississippi and making their way down to the Gulf of Mexico. But even here, it's possible to diversify. And you can, some farmers are adding prairie strips on 10% of the farm area. And in doing so, this greatly reduced pollution and also enhances biodiversity in this intensive corn soy cropping system. And you can see in the inset what that prairie strip looks like close up. So this is the work of Lisa Schulte-Moore. Again, a spider diagram here. She's at the University of Iowa and just won a MacArthur fellowship herself this past year for this work. And so let's start by looking at the important effects on pollution reduction, which I mentioned in the previous slide. Really, they're very strong. So up to 90% reduction in sediment loss, about 70%, 80% reduction in phosphorus loss due to integrating these prairie strips, which is really, really important. There's also important positive effects on biodiversity, about a 3-fold increase in pollinator richness and abundance, and a 2-fold increase in bird richness and in the abundance of birds of special conservation concern. As far as the production and profit, however, there is a reduction in production, about 10%, by taking out 10% of the field's area and putting it into prairie strips. Not surprisingly, there is a reduction in yields and a reduction in profitability as well. But it's a fairly small reduction for the huge benefits that are being seen in terms of the pollution control and the biodiversity. In addition, the profitability is not significantly different, but it is a little bit less. And this is a huge impediment for trying to promote these practices more broadly. In addition to prairie restoration, which creates these deep-rooted plants that really help to hold the soil in and reduce these polluting effects, there are also a number of other things that are being tried by farmer innovators in the Midwest, including cover cropping and diverse crop rotations, as well as livestock integration. And this is a farmer demonstrating what happens when you use some of these techniques in terms of building healthy soils that are resilient to drought and floods. And in the really extreme drought that happened in 2012, the top image is corn that was grown following a diverse cover cropping. And then the bottom image is just conventional corn in that same year. These are two side-by-side farms, and you can see the top farm is still producing some corn, although it's a bit smaller than it normally would be, whereas the bottom field was not able to produce any corn at all. So this is an anecdote, but it's backed up by a study that my colleague Tim Bowles at UC Berkeley just recently conducted, and there he brought together data from 11 experimental sites in North America that looked at different kinds of rotations, so crop rotations, comparing maize yields grown in the simple rotation, corn yields, which would be just basically the corn-soy rotation, against corn grown in much more complex rotations, including a variety of other plants. And so in this graphic here, this is showing each of the different 11 experimental sites, which collectively bring together 347 site years of data. And in 9 of the 11 sites, how to read this graphic is that when the point, which shows the mean effect and its error bars, when it's fully above this dotted line, then it means there's a significant effect. And that was the case for 9 of the 11 farm sites. And on average, the more diverse rotations increased mean yields by 28%. But you can see that it's a much larger amount in certain sites. And they also identified the years with the most stressful conditions on each farm, and then compared in that particular year the most complex rotation against the least complex rotation, and found that, again, there was a strong effect of rotational complexity on maintaining yields even under these stressful conditions. And identifying when those stressful conditions were drought conditions, they found that the most diverse rotations reduced yield losses by 14 to 90%, depending on the experimental site being studied. So moving on to another synthesis, one that I've personally been involved with, we looked at the effect of diversification practices on a variety of ecosystem services and biodiversity. And I'll give you the punchline now. We found that these diversification practices enhanced both ecosystem services and biodiversity, but were neutral on production. So they didn't reduce production. And this study is a meta-analysis of meta-analyses. So in other words, we brought together 69 meta-analyses that were based on over 38,000 original comparisons. So each study compared a diversified practice to a conventional or more simplified practice, and our diversification practices included some of the ones that I've discussed already: crop diversification, non-crop plantings, adding amendments to the soil, which we consider a diversification practice, again, because it provides both, it provides resources to that soil and helps to create soil aggregates that actually build habitat within the soil. Reduced tillage that similarly affects soils by allowing them to be undisturbed and enhancing them as a habitat. And then finally, organic agriculture, which uses multiple aspects of the above diversification practices. And so in our graphic here, we have these different ecosystem services on the left, and you can see that for most of them, we found a positive effect of the diversification practice compared to the more conventional or simplified practice, but that for crop yield, we do not find a significant effect, meaning it's neutral on crop yield. We have about as many observations that might have had a positive effect from one of these practices as a negative effect. And now zooming in the same study to those, a subset of the studies, 24 meta-analyses that looked at both the effects of diversification on crop yield on the y-axis, and also of an ecosystem service response on the x-axis. We can look at this upper right quadrant, the win-win quadrant, where we have increases in crop yield in response to diversification, and also increases in whichever ecosystem service was being studied. And we see that about 66% of our observations are in that win-win quadrant, which was a bit of a surprise. We actually find that more often than not, there are wins in yield and an ecosystem service. So now I want to talk about some results that we've just generated from a SUSINC project. That's the National Socio-Environmental Synthesis Center. And in this project, we brought together 24 studies on the effects of diversification strategies on both social and ecological indicators. And the key here is that we're crossing from the social to the ecological. Most studies have looked either at the effects of diversification on ecological aspects or on social, but rarely bringing them together. And here we were able to bring together data from over 2,000 farms on 5 continents, and they include a huge range of different kinds of farms, from smallholder subsistence farms up to large commercial farms. And we looked at 5 different diversification strategies. Those were livestock diversification, temporal crop diversification, such as crop rotation, ecological nutrient management, which is mostly having to do with soil amendments, but could also be, for example, intercropping with legumes, non-crop diversification, such as using field edge plantings to promote pollination or pest control. And then finally, soil and water management, such as contouring, for example, to maintain soil structure and water in the field. And as mentioned, we looked at both environmental outcomes and also socioeconomic outcomes. And these were quite diverse depending on the study, what we bin them into these different categories. So we looked at indicators of biodiversity, indicators of ecosystem services. For reduced externalities, that refers to reduction in input use. And then for socioeconomic outcomes, we looked at yield, but also at measures of food security. And for human well-being, we had actually a large number of indicators, over 20 indicators, dealing with not only economic factors, but also mental health, learning, social supports, knowledge access, labor components, employment satisfaction, and most of those consider gender as well. So our main preliminary conclusions, and I know this is a very complex graphic, but I'll guide you through it. Our main preliminary conclusions are that several strategies, the two outlined in red, promote win-win socio-ecological outcomes. And that's really what our interest is in looking at the social and the ecological. So for example, the livestock diversification, you see that we found significant positive effects of livestock diversification, not only on biodiversity, but also on human well-being indicators, food security, and on yield. And our second main preliminary conclusion, I do want to stress these are preliminary because we're still working on this. We found that 3 strategies drive increased food security. And this was all for smallholder farms less than 2 hectares, because it's only such farms in which we had data on food security. So we have the strategy of livestock diversification, ecological nutrient management, and non-crop diversification, all having large positive effects on food security. And that's important because many governments pursue chemically intensive, simplified agriculture in the name of promoting smallholder food security, but it's often not successful. And instead, our results are suggesting that agroecological diversification is a promising alternative to support food security for smallholders. And that not only that, it also provides additional benefits for biodiversity and other aspects of human well-being. So just to sum up on this first question, our case studies provide examples where multiple benefits are realized simultaneously. The reviews and syntheses suggest results may be generalizable, and they also, in this recent work, this recent succinct work, extend from ecological benefits to considerations of food security and other aspects of human well-being. So now I want to turn to barriers to adoption and a promising avenue to scale up adoption of working lands conservation. Because I'm sure you may be wondering, given so many benefits, why are these kinds of diversified farming systems not more widespread? In fact, why are things pretty much going in the opposite direction, where the conventionalization, intensification, and scaling up of agriculture is much more predominant in most places? So the barriers to adoption are actually very well known, and this is probably a partial list. But one of the big barriers is that it can cost something to transition into these kinds of approaches. So the upfront costs can be difficult. There can be initial yield losses when the farmer is learning how to use these new techniques. A second is simply that people are risk averse and don't necessarily like to change their practices. There can also be lock-in factors due to capitalization, for example, in certain machinery or equipment. There can be economic trade-offs like we saw in the prairie strips. It can be that farmers would like to adopt these practices, but they have limited economic or capital resources that would allow them to do so, and limited access to credit. They may have lack of secure access to land and thus little incentive for long-term investment. They may have lack of access to labor. And in all these last 3 cases, they might wish to do these practices, but not have the means to do these practices. Also, these practices are typically more knowledge intensive. They require either farmer to farmer or NGO or government extension, such as, for example, in the push-pull system, in order for a farmer to have the technical assistance and be supported to undertake them. There can be lack of access to appropriate equipment, seeds, breeds, or the rural infrastructure to implement one of these techniques. And there can be lack of access to market options. I'll mention that a little bit more presently. And then finally, there can be lack of incentives from policies or regulation, or actually disincentives from policies or regulation. So in a system where I've worked quite a lot in California organic agriculture, we found that, interestingly, there's a sort of sweet spot in the mid-sized level of farms. So on either side of that, very small farms, 1 to 20 acres, we found were mostly limited in being able to implement diversification practices because they have very insecure access to land and financial resources. So this is an example of what I was talking about before. So they simply might like to adopt some of these diversification measures. Typically, these very small farms grow multiple crops, but they're not able to really do cover cropping or various ways of maintaining their soil fertility because they don't have the means to do so. So they're limited by their lack of access to resources. But then on the very large scale side, they also are under extreme economic pressure, but it comes from other sources. So these are highly capitalized farms, but they have very, very slender margins and high risks. And furthermore, they're very constrained. They manage their farm very precisely using lots of inputs, even though they're organic inputs, but they still use lots of purchased inputs. But they're driven by supply chain constraints. The shipper buyers in the system really dictate a lot what the management practices must be, and most of that is driven by food safety concerns. So, for example, if a farmer has implemented previously a hedgerow on their farm, there are auditors in the system that will often tell the farmer to take it out because they're concerned that wildlife will vector E. coli or other pathogens onto the farm. And so most growers are doing exactly that. But then in the middle of these mid-sized farms, these are farmers that typically own their lands or have long-term leases for their lands. And they have much more agency. They have multiple market outlets, and those market outlets are often buyers that have shared ecological values, whether it's a community-supported agriculture or farmers market or high-end restaurants or certain grocery stores. They're able to sell their products to a variety of different places at a premium, and they're able to practice a flexible, diversified management that is really responsive to the ecological conditions. And so that's what we call the sweet spot in the middle. Interestingly, by coming to this understanding and identifying this sort of bright spot in the middle, we thought about how could we move the needle then on California agriculture for these other two situations, for the very small and the very large farms. How could we generate policies to enable adoption of diversification strategies in these two cases? So in the very small farms, really the issue is helping farmers to secure longer term land access and financial credit. That's what they need so that they have the resources to be able to implement these kinds of diversification practices. But it's also about helping them to utilize some incentive programs that already exist, such as the Farm Bill's EQIP program, the Environmental Quality Incentive Program. And this program is notoriously difficult for many farmers to access because the application process itself is so difficult. In addition, a lot of these particular farmers don't necessarily even know about the program. So it's important to publicize it and provide enrollment and technical assistance. And some of that could be accomplished by facilitating sharing among peers and with farmer to farmer. That's often a very good way to get farmers to adopt something. And then on the other side, it's really a very different situation with these large scale growers. What they really need is help negotiating with their buyer shippers, for example, on food safety issues, so that they might be able to use practices that would actually be very beneficial to them, like being able to use compost. They used to be able to use compost, and now there's a lot of pushback against the use of compost. These are organic growers, so they really need that to maintain their soil fertility. So helping to bring the science to bear with the buyer shippers so that people aren't trying to do things for food safety that actually aren't necessarily particularly helpful. And then also helping them to have more alternatives for markets that value ecological management. And this can sometimes happen through large scale public entities like schools and hospitals. And then it can also be a bit of a carrot and a stick, using regulatory mechanisms to encourage the uptake of diversification practices that would help with other issues such as water pollution. Again, this can be a way of encouraging uptake on these large farms. But I want to talk about another way forward, which is the idea of identifying, retiring, and restoring marginal lands within farm fields. So what are marginal lands? Marginal lands are lands where are tiny bits of the farm where the production is less. And in an example from the United Kingdom, they use precision agricultural techniques to identify these areas of lower productivity. So on the left graphic here, at every single point, the harvester can actually detect how much yield, how much is being harvested at each point. And so it's possible to identify areas that have lower versus higher yields. And here they compared the edge of the field with points in the interior of the field for the 3 different crops grown in this rotation. And they found that for each of them, the edge condition in the dark histogram produced a little bit less than the interior of the field. And so based on that, they set up an experiment in which they dedicated some of these edge habitats to habitat plantings. And so they also had control fields cropped edge to edge. This is one very large farm, and this is just a few fields within it. And here you can see where some of these habitats were placed along the edge. And again, there were some fields that were controls. The potential benefits that they expected would be that potentially pollination and pest and disease control might be enhanced. That could lead to some economic benefits, including both reduced inputs and labor on the lands that were being retired, as well as potentially increased yields in the remaining cropped area. And also the possibility for incentive or compensation dollars for these plantings, which in Europe are supported through an agri-environment scheme. So growers are actually paid to do these kinds of practices. And in the United States, as mentioned before, some of these practices are also supported through the Farm Bill EQIP program. So what they found, interestingly, was across all crops, the yield was significantly enhanced in the remaining area of fields when there was the planting, the 8% planting, the 3% planting compared to the control. And that increase in production was large enough that across the entire field, there was no difference in total production, despite removing up to 8% of the land. Profits were also not significantly different among the treatments. So there was a huge compensation effect by being able to produce more in this smaller land area. And it was probably due to the pollination and pest control benefits, because they also documented that there were enhanced pollinators and pollination on these crops. So to sum up this piece, what are the barriers to adoption and a promising avenue to scale up adoption of working lands conservation. As I've noted, there are many well-known barriers to adoption of more sustainable land management practices. But what our study shows is that context matters a lot, and different policies will be needed for different types of farms. And then I find that this idea of identifying, retiring, and restoring marginally productive lands within farm fields is really exciting because it can align economic and ecological incentives and maybe provide an intrinsic motivation that doesn't necessarily need that policy lever. But it's still hard to get started on these techniques. And so it's important to continue incentivizing them. In Canada, where there is no program, no governmental program for these kinds of incentives, there are several NGOs that are doing this themselves and are providing incentive programs to farmers to restore on-farm habitat on marginal lands. So the policy guidance here is that even with this marginal lands idea, we still need to incentivize it through government programs. So what about if we were to do this working lands conservation, what would it look like from landscape to global scales? So with my colleague, Lucas Garibaldi, we've looked at what the target should be, how much land, if we were to think about conservation and working lands in terms of restoring natural habitat patches, what should be the target be? And we've done a large review that has essentially supported the idea of needing at least 20% of these landscapes in order to realize the ecosystem services and biodiversity benefits. And here, there's 5 different sort of intensively farmed landscapes and as examples in different parts of the world. How would we go about doing it? Well, the idea would be to start with whatever is existing in the landscape already, whatever natural habitats already exist, these little bits of green, and then restore around them, again, targeting those marginal subfield areas whenever possible, and also the edges of fields and the edges of roads, as you can see here, and making sure that sensitive areas like wetlands and steep areas are protected or are restored. Together, we can ultimately promote more connected landscapes in this way, and that can contribute to a major policy objective that's being adopted pretty broadly around the world, including in the US and Canada, this target of 30% of terrestrial and aquatic landscapes by 2030. And related to that, at the global scale, we've recently mapped connectivity globally and in a functional way, looking at the critical linkages for mammalian movement. And I apologize that this slide is a little bit fuzzy, but what we found is that about 1/3 of the critical linkages overlap with land suitable for agriculture. And in such cases, actually outright protection is not always going to be possible. And here, working lands conservation may be effective instead. So I'm going to sum up now. So I've shown you that many examples show how diversified land management techniques can support multifunctionality for biodiversity, ecosystem services, and production, and can also promote resilience. Our meta-analyses and syntheses support the generalizability of this and extend to food security and human well-being. But of course, many barriers are preventing broader adoption, but both very small and very large farms face different barriers, and thus policies to address each case must also differ. The restoration of marginal lands within or around fields is a promising avenue to scale up adoption of working lands conservation. And although it may ultimately be economically viable, we still need policies that promote policy from government for incentives. We should aim for conservation and restoration of at least 20% within working lands and use working lands conservation to create permeable landscapes focusing on the most important movement linkages and climate connectivity. And this latter goal fits with the 30 by 30 target adopted in Canada, US, and 90 countries to support the High Ambition Coalition for Nature and People, and the Global Ocean Alliance. So to conclude, I hope I've convinced you that we can and must work on these problems of climate change and biodiversity simultaneously, and the role of working lands conservation and nature-based solutions in doing this. We mustn't forget, though, that the resource consumption driver of climate change and biodiversity loss. I haven't spoken about this, but within the food domain, the answers are clear and well known. We need to reduce food waste and meat consumption and increase fruit and vegetable consumption. But here I focused on changing the land management piece and how nature-based solutions and working lands conservation can provide great promise for replacing resources extraction with sustainable and multifunctional methods that build our resilience and adaptive capacity, so that we do have something to leave for future generations of diverse people and for biodiversity. And so I want to thank you for your attention and move on to the next part of our program.
Great, thank you. Jeff and I will have to clap extra loud since you can't see anyone else out there, but thank you very much. Just a reminder before I give the floor over here to Dr. Jeff Walters for the response, that if you would put questions into the Q&A area at the bottom, please, and then we'll come back to those in a few moments here. And with that, Dr. Jeff Walters, the floor is yours.
Thank you, Todd, and thank you, Claire, for a wonderful seminar, just full of things to think about. So I'm going to ask you about a couple of things just to get the discussion started before we open it up to general Q&A. And first, I wondered if you might talk more about your engagement as a scientist with the policy process. There's obviously a lot of interest in the science policy interface among the graduate students in the STEP program, as well as in other programs like the interfaces of global change associated with the Global Change Center. Doing excellent policy relevant research and communicating it effectively within the science, within the academic community, as we've just seen you do, are certainly important ways of engaging with policy, but I'm curious about other ways you've engaged in the policy process and whether you might have any advice or acquired wisdom about engaging with policy to pass on to our students.
Yeah, thank you for the question. I think I always find this a difficult question to answer, and maybe to answer concisely. I would say that probably my own most or strongest engagement with policy was when I worked in Madagascar for a conservation NGO, and we were tasked with implementing, or actually not implementing. I guess the first task was to identify where we should place a protected area within a integrated conservation and development framework. And being in a situation like that, where we were actually tasked to do so, was an important way, it provided a real avenue for influencing policy. And so I think that to some degree, it's being in a situation where you are at the table to talk to policymakers, and you can then bring to bear the scientific considerations, which is what we were asked to do. We were asked to bring the biodiversity perspective and the human socioeconomic development perspective together in the park design process. So that was really a great experience because we could plug right in with the science. I think that right now, the group that I'm working with in California, we have quite a large group. We are trying to figure out how to make our results count and how to get them communicated and into the stream. There's a lot of it's a really large playing field. There's a lot of different actors. There's a lot of moving parts, and it's really challenging to figure out how we can actually influence, get the information out there. And so we do things like, of course, outreach talks at different levels, whether it's talking with farmer practitioners, which I think is a really important level, or talking with policymakers in California governance, or going to the Capitol and talking with people there. I've been involved in all of those kinds of ways. Talking with the grower shippers, that's actually really important. I know I'm not doing that, but several of my colleagues are doing that. That might be one of the most important aspects. So I think that it's usually not just one way. You've got to find multiple different strata of society that are influencing the problem, and you have to find the way of talking to each of them. And it's not talking at, it's talking with. So participating in these multi-stakeholder engaged workshops is I think one of the most important ways to go about it.
Okay, thank you for that answer. And my second thing I wanted to ask about has to do with climate change and how that might affect wider adoption of the kinds of practices you're talking about. A common thread that ran through all aspects of your work, really, from the Midwestern corn soybean system to the silvopastoral system to your meta-analysis. You talk specifically about this with when you're talking about the small farms, and what you've learned there is that these systems are more resilient and perform well under maybe extreme conditions. And to me, this has profound implications that go beyond food security and agriculture. For example, I wonder whether widespread use of such systems might reduce the number of climate refugees, especially those that come from extreme events. And an example familiar to us in the US here is the mass exodus of people from Guatemala to our southern border in response to drought-induced failure of the corn crop in 2018. And I wonder how many of those people could have stayed at home on their farms in Guatemala, which is what they really wanted to do, if agricultural practices were different. So my question that I'm finally getting around to is, given this resilience, might climate change actually create more opportunities and more openings to get wider adoption of these kind of practices, not only because of food security, but all these other things that come along with climate change?
Yeah, I think that's a wonderful question. And I hadn't thought about the refugee piece, but I think, I mean, that would be a wonderful subject to document, because it could be compelling. It could be a really compelling angle for policymakers if they realize that possibly the way that we're promoting agriculture is exactly the wrong way to keep people on their own farm instead of trying to go somewhere else. That could be quite compelling. I hadn't thought about that, but yeah, I do think that these kinds of techniques, they really do have both an adaptation and mitigation potential. And looking at food security, I mean, it makes a lot of sense because a lot of the people that you're talking about are doing, they have small land holdings, they're smallholders, they're pretty much on the edge. So if there's the slightest problem, they're going to go below the edge, and they're not going to be able to stay there anymore. And so if they have to buy inputs, if they're sort of really on the whole bandwagon of this more intensified agriculture, and there's a drought, they're not going to be able to afford those inputs anymore. Also, if they're producing a single cash crop, they're not providing for their own food security. And so, it's quite amazing how many places keep promoting these much more intensive agricultural methods as a way to enhance food security of smallholders, but it's really not doing it. It's sort of the opposite. It's making it much more brittle system, much more difficult for these people, and it isn't giving them the agency to grow the food that they need for themselves. So yeah, I think that not only are the methods more drought resilient, but also simply being able to produce for your own needs is a better way to go. in these kinds of conditions, in these kinds of conditions where we have so many extreme events and surprises.
Yeah, it all makes so much sense. The hope is that more and more people will realize how much sense it makes.
Yeah.
With that, Todd, I'll turn it back to you for the Q&A.
Great, thank you, Jeff. If it's okay, Claire, I'll just read the questions here and we can
Sure.
go from there. Great, okay. I was pleased to see the first couple of questions come from graduate students in STEP courses. I'm going to combine the first part of Gates' question and Elizabeth's questions. I think they're very similar in nature. So first of all, Gates says, thank you for an interesting talk. In terms of, these are really questions about scale. So Gates says, when thinking about policy or regulatory measures that can be taken to adopt working lands conservation, what level of government can or should be engaged, local, state, federal, and how can or should engagement strategies differ? And I think in some ways, Elizabeth's question is very similar. So she says, for countries that do not have policies addressing multifunctional land use, would local or national policies have a larger impact? For countries that do have national policies like the Farm Bill, could state level policies address the educational and financial barriers facing farmers, or would it be better to invest in the existing national policies? I think it's really about efficacy at different scales there.
Yeah, well, I think usually you probably need multiple scales of policies. I think that agriculture is very responsive to policy. I mean, you can see that. You can see, if the policy, we have big policies in the United States. We have the policy that kind of at one point gave subsidies to Midwestern corn or Midwestern farmers to grow corn and soy at a large scale. And that's why we have corn and soy in the Midwest. It's not because it's because they can't grow other things. They can grow all kinds of things there, but they grow corn and soy because we had policies that incentivize that. So agriculture is very, very responsive to policies, and that certainly plays out at the federal scale. Just in the same manner, we could change those policies, and those policies could be promoting a much different type of agriculture. But should we have policies at the local and state level? Absolutely, because and you mentioned engagement strategies as well. I mean, engagement strategies are going to happen at a much more local scale. Yeah, I think that we really need a mix of those. And then for the other question, could state level policies addressing educational and financial barriers facing farmers? Yeah, I don't know that I can really shed too much light on that. I am a scientist and not really I'm not a policy expert, so I probably wouldn't say anything very intelligent and answer that question, unfortunately.
Oh, thank you. Maybe if we can go to the second part of Gates, so the second part of that first question just for a moment. And, yeah, the question here is really focused on policy or international agreements. I'd be curious if we expand that to what you see as benefits of international collaboration, whether in policy or something else. But really, at its core of this question is about what do we do internationally, given how international agriculture is and these issues like climate change are. Yeah,
I mean, I think there is a potential for international agreements. I mean, I mentioned the 30 by 2030, and there's the Convention on Biological Diversity is going to be meeting again this summer, and 30 by 30 seems to be what everyone's working towards at the moment, and I think that working lands conservation could play a role in that, but that's going to work a lot better if it gets recognized in the upcoming meeting. So I think that because typically people seem to think about 30 by 30 as protecting intact regions. The working lands conservation isn't really seen as part of that, but there's something called other effective conservation measures, which it's a vague term, but OECMs, and we think that this working lands conservation could fit in there. Certainly governments that are signing on for this 30 by 30 are looking for ways to do that in ways that are least disruptive to other other economic interests. And so there could be an interest in working lands conservation from that perspective, particularly if we can start to use some of these more marginal areas within fields or around fields, so that it's less of a hit on production and less of a hit on profitability for individual farmers.
Thank you. Anonymous attendee lurking in the shadows has asked, and I'm not sure how much you want to tackle that, but the magic wand question: if you had one policy that you could make happen, what would it be? Do you have a favorite policy from those or one you would love to see implemented?
Ooh, I clearly should have tried to identify what these questions are going to be in advance. These are hard. One policy, I think that, the thing that tends to bother me the most is the unequal playing field, and that the sort of, it's not even the large scale growers, because I think all the farmers are similarly, it's just a really difficult lifestyle. So it's not like it's not easy for any of them. But it feels like more resources keep going to the conventional way of doing business. And it's probably as much the agribusinesses that support those as it is the farmers themselves. So I'd like to see the playing field leveled in some way, so that these smaller growers or these less capitalized growers have access to resources, so that they can, they can do this more ecological style of farming. It doesn't feel like there's a very level playing field. So I haven't really answered your question, because that's not giving you one policy. It's more giving you like one wish.
There are various questions here that kind of, I'm trying to quickly skim through to put some together for the sake of time, that get at this notion, maybe of the answering the why that doesn't happen, right? Why are those policies not available to small holders, for example? Gates' question there is around, how do governments, farmers, and corporations, how are they, maybe is there some synergy, but conversely to that, how do factors like lobbying come to play? And if we look down below, we see, could you speak a little bit to how subsidies for big agriculture in the US are part of the problem and or could be part of the solution? So have we set things up certain ways because of the structure, because of the way we support big ag, or is that a problem? Or where is big ag and small ag and so on, and these various players you've talked about on the same page, and where are they divergent, I guess?
Yeah, I really do think that the corporate lobbying and the corporate power is a huge reason why we have the agriculture that we do. And again, I don't put it really in the laps of the farmers. I put it more in the laps of the agribusinesses. And, I think some of the examples are those who supply the agricultural industry. There's quite a small number of them. They're rather large, a small number of very large companies, and they seem to be getting bigger, a smaller number and bigger all the time. And so it provides, it means that they have a lot of power over what growers have to choose from, even in terms of seeds. So, if you look at corn and soy in the US, most of those seeds, the seed available is GMO seed. And most of it is also wrapped in some sort of pesticide like a neonicotinoid. So that doesn't provide growers with a lot of choices. And in addition to which, they get a lot of their information from the same agribusinesses. And those agribusinesses have a huge amount of lobbying power. So they probably have a huge influence on, what the subsidies structure has been, and now it's more on crop insurance, but they similarly have a lot of control over that. So that tends to maintain the system and the status quo, even if we all think, well, this isn't the best system. We'd like to change this system. So we were talking before about how policies do really make a difference. But if you can't change the policies, then you can't make that difference. So I do think there's a huge amount of control there. And then on the other side, I mentioned a little bit of this in my talk, are the those who are buying the agricultural produce. And again, they have become very powerful and very, it's a small group of very powerful actors. And so again, they have a lot of power over what happens, and it's extending to exactly how a farmer actually manages their farm field. And then there was another question about, sorry, I have to read that one. Land use choices in this. Yeah, I think that, so the question was, the trend for ag land use is increasingly conventional and industrial. Land use choices are mostly made at local scales by millions of individual farmers who commonly are not familiar with current scientific knowledge. What are some of the key institutional levers that can be pulled to nudge those incremental choices towards more sustainable outcomes? Again, I think that I think our work shows, and I haven't been able to describe all of it, but that it's not just about knowledge, but it's about agency. And then, a lot of the individual farmers may not have much agency to make much of a choice if they, if the governmental support system is such that they can only grow they can only grow corn or soy, and then the seed that's available is only of a certain type, then it kind of channels them in a certain way. So it's kind of going back to what we were talking about before, that it's important to be able to change some of these policies to be able to support alternative ways of growing. And I think that being able to break up some of these monopolies would be a good idea.
No, that's I really liked Paul's question, though, in the sense that does, this seems to be a core thrust here, right? Where's the locus of control, right? Is it with the farmer? Is it with the system? It seems like you're suggesting it's with the system, which, as people interested in policy and interactions of policy and science, agriculture, so on and so forth, that seems like good news for us in a way. Maybe there's opportunity there at least to pull those levers. The next one I think is very interesting as well. Another anonymous attendee asked about, you kind of identified one of the barriers in that kind of sweet spot, for larger farms in that sweet spot, being that they're pushed by regulation or by the practices, agribusiness practices, to address or prioritize specific food safety concerns. And this could be an example of two different well-intentioned cultures clashing. Do you have examples of where that clash or how that clash might be resolved?
Well, it seems like it hasn't been resolved. It's just been completely controlled by the food safety regulators and the grower shippers at this point. But the team that I work with has been really looking at, to what extent do features like hedgerows actually promote food safety issues? Does nearby natural habitat promote food safety issues? And the answer is no in both cases. What we think is probably a bigger problem is when there's livestock nearby, but when there's grazing nearby. But we're trying to get that research out there, but it's not really, so far it hasn't really made a difference. It is possible that there might be several different regulations that could come together that would then start to build more of a case for this. So if we can convince the grower shippers that having things like hedgerows or riparian buffers is not really going to create more food safety issues. At the same time, there's a policy in California right now that's aiming to control the nitrogenous waste going into the rivers and the coastal waters at the watershed scale. So it's like the whole watershed has to get better. And so riparian buffers are a well-known way of doing that. So building those back in could respond to that policy, and farmers are going to need to do that. So what really needs to happen is maybe even more research on the role of hedgerows, or the lack of role of hedgerows, in causing food safety problems, that could hopefully compel the food safety regulators to allow that to be okay, so that farmers can do the other thing that they have to do, which is reduce pollution. So that's still a lot of steps, and it's not going to be easy, but that's where our group is kind of trying to go.
Well, the lots of steps, if it's okay, I hope folks will forgive me. I'm jumping down a little bit just because I think it's a nice corollary, and I'm not going to read the whole question, but Kent Mendoza's question down below suggests that to some degree is that part of maybe the problem is that this is complex, right? And we industrial agriculture works certain ways, partly because it's been so systematized, in some ways simplified. So is that part of the challenge here in some ways, is that, and how do you overcome that? Or as Ken says, how do you articulate the need for context-dependent solutions when people want easy answers?
Yeah, it's a really good question. And I think maybe it speaks a little bit to one of the earlier questions about the local, state, federal, because yeah, I mean, you're going to end up with some sort of big one-size-fits-all solution, maybe at a federal level, but you can start to break that down at smaller levels. And I mean, one way that the way the Farm Bill works, for example, is that it sets up a way of providing funding for a variety of practices that are positive for the environment, but it allows states to actually dictate and determine which practices. And you need to do that because, it's different agriculture in different places. So it absolutely has to be done in that way. So I really can't see what else we could do.
One is, and again, I'm hoping people will accept the prerogative to jump around a bit, just because I think there's some connections. Not that there aren't other good questions, but another anonymous person asked about the connection to land-grant universities. So you mentioned, that the national to local policy, but what about extension through? I mean, this is a very important question to us at Virginia Tech.
Yeah, absolutely. I mean, so the land-grant universities can play a huge role through agricultural extension, but they do what they do based on funding too. So funding comes through grants like USDA. I think that we've members of the Center for Diversified Farming Systems back at Berkeley looked at how much funding the USDA provided for organic agriculture, just as an organic agriculture is not the same as necessarily as diversified agriculture, or someone asked about radical agroecology. Organic agriculture is, at this point, has been pretty conventionalized. But even that, I mean, it's like 1% of the total funding goes to that. It is such a small amount, so that playing field is not leveled there either. So when you think about it, so how much of the ag extension from land-grant universities is going in this direction? Probably not that much of it, based just on that as an indicator. And then you also have a lot of ag extension is funded by corporate entities as well. So again, it's sort of, we need to shift the whole system so that we can have more ag extension oriented in this direction, and towards a sustainable agricultural management.
Yeah, and if I realize we're getting at time here, but maybe a nice last question there, and I apologize to those who didn't get to, but would be at least a sub part of my colleague Ralph Hall's question here around, you just mentioned the ways in which extension, can be top down. And I think the suggestion here is that blockchain technology could be used as a more to level the playing field in a way you were just talking about, allowing information to be more democratized and spread in different ways. Do you have any experience with that, or have you seen effective uses of that?
I do not have any experience with that. It sounds like Ralph Hall maybe has more experience with it than I do. So yeah, I don't know. I don't have experience with how blockchain technology could be used.
All right. Well, I see we're at time here, so I think would be only fair to wrap up. We could keep the conversation going, of course, forever. There's been lots of great questions here. And so, of course, thank you for the great questions. Thank you, Jeff and Amy, for your remarks today. And of course, most importantly, thank you so much, Claire, for joining us for this keynote. It was wonderful to have you join us. And yeah, thanks again to Isabel as well for helping us pull this together in terms of inviting you and so on. So it's great to have you. And thanks everyone for joining.
Thank you so much.
Thanks, everyone. Recording here. There we go.